So about 2 years ago, ChatGPT came out, and I and most other AI researchers did not anticipate such a quick evolution in AI capabilities. So now we have AI systems that understand language and that master a lot of knowledge. They still are weak on reasoning and planning and autonomy, but it's been such an impressive milestone that a lot of people like myself, and for example, Jeff Hinton, who got the Turing Award with myself and Yann Lecain, we started, asking the question, what if we succeed? What if we build computers that are as smart as humans or smarter than humans? What are the consequences? What are the benefits? What are the risks? And a couple of months after ChatGPT came out, I decided that we were on a dangerous path because we don't understand all these scenarios, and some of these scenarios could be catastrophic. Some of these scenarios could be beautiful, but we need to know where we're going. Today I'm going to tell you some little bits of my journey, and most recently my thinking about the notion of agency or autonomy, which has to do with the ability to decide for yourself what you're going to be doing, plan over a long time in order to achieve goals. And we humans are very good at that. Every living thing is pretty good at that. But it's not clear whether we want to build machines that are autonomous and are like their own entity, maybe like a new species, or maybe we should be prudent and build machines that are more like tools that can help us do things, understand things in the world, build new technology. These are different goals and different risk to benefit profiles. So that's the summary of my talk. There is a concept in science called the precautionary principle. In Wikipedia, it defines it as the approach to innovations with potential for causing harm when extensive scientific knowledge on the matter is lacking. So that's the problem we have with AI. If we build machines that are smarter than us, they could do great beneficial things, or they could create a lot of harm. And I will give you some examples. The problem is we don't know enough. So we don't have enough ability to predict what will happen. So that's the scientific knowledge on the matter is lacking. And in that case, this principle of precaution emphasizes caution, pausing and review before leaping into new innovations that may prove disastrous. Okay. So to put things in perspective, you have to understand not AI as it is now, but you have to think of the trajectory so we can imagine the future. So here's some numbers. Between 2018 and today, on average per year, the amount of training compute used to train the largest models, the frontier models, multiplied by 4 every year in average. Do you know some things that get multiplied by 4 every year? Not so many things, right? That's a very fast exponential. The efficiency of exploiting data, how much data you need to achieve a particular level of performance, improved by about 30% every year. That's actually a lot. And that's just improvements in the algorithms, right? It's not the compute, it's the algorithms. The efficiency, the computational efficiency, so how much flops do you need to achieve the same result? Tripled. So 3 times more efficient every year. You notice that it's not as much as the amount of compute. So we still, the actual like compute efficient, effective compute is 3 times 4. That's 12, right? Because our software gets better and we get more hardware. And the investments in AI have averaged in that period $100 billion per year. And it's rising by 30% per year. Okay, so that's sounds like a lot. And the capabilities of AI systems have been also improving year to year. You can see different benchmarks used in machine learning. And the black line is human level performance. So the old benchmarks already are useless because the computers are better than humans on these old benchmarks. On the new benchmarks, not yet, but you can see the trend, right? I got this award called the Turing Award, which is considered the biggest prize in computing. But Alan Turing was one of the founders of computer science. And he was a genius. And he was thinking ahead in the 40s and 50s. He was concerned that one day we build machines that are smarter than us and that we might not find a way to control these systems. Unfortunately, we are approaching, his concern. We are building machines that are becoming closer and closer to human performance in many areas, but we still don't know how we can control them when they get smarter than us. That's a big problem. So why do we continue? Well, there's some estimation that when we reach AI with human level, the net present value, the economic value, is on the order of quadrillions, $10 quadrillion, right? So if you had a company that was controlling that market, this is how much the company would be worth. Quadrillion is 1,000 trillion, a trillion is 1,000 billion, okay, so that's a lot of money.
Million.
Yes. Millions of billions. Millions of billions, yes. Okay. So right now there are people who are saying maybe this improvements in capability due to bigger and bigger systems, so-called scaling, is close to the end. Actually, we don't know. But also what is happening is other forms of scaling are happening. So what's called inference scaling. So it's not just the compute to train the system, but at runtime, you can allow the system to think more. So that's system 2 kind of approach. Finally, the companies understand that we need to have AI that thinks. And that's what you find in OpenAI's O1, but Anthropic has their own version. I assume also Google, but we know less about that. And just in the last year, for example, Anthropic's AI system is probably the best currently for software engineering, programming. And it went from 3% quantile compared to human programmers to 49% in less than a year. So I think it continues, getting smarter. We don't know how fast it's going to go in the future, but we have to think ahead. What if it's fast? What if it's slow? And be ready for all these cases. I'm chairing an international report inspired by the IPCC, the International Panel on Climate Change. But this report is a panel on AI safety. And we had a first interim report that came out last May in Seoul, and would have a final version in February in Paris. In the May version, we wrote this: as general-purpose AI capabilities continue to advance, risks such as large-scale labor market impacts, people losing their job because of automation with AI, AI-enabled hacking, cyber attacks, thanks to making it easier for people who are not experts to make cyber attacks without having the expertise, but using AI to help them. Biological attacks, designing bioweapons. I can kill lots and lots of people because, viruses can reproduce. Or even worse, which is society losing control over general purpose AI. All of these things could emerge. They haven't happened. I mean, we're seeing more and more cyber attacks already, but not to the point where it's kind of disrupting society completely. But we see these dangers emerging. For now, mostly on the small scale. But what is it going to be in 2 years, 5 years, 10 years? Okay, now, what happens when we reach human level? Actually, we don't need to reach human level on everything. The leading AI labs, they're not trying to just get all the skills, all the human skills. They're just trying to focus on one skill. Machine learning research, right? They want to build an AI system that is as good as their best AI researcher. So they want to create an AI that can do AI research. Now, let me explain something important. When you train one of these systems, like GPT-4, let's say it takes 100,000 GPUs to train it. Once it's trained on these 100,000 GPUs, you can run 100,000 copies of the AI in parallel. In fact, it's equivalent to more than that because AI are not like people. They can work 24 hours a day, 7 days a week. Even Vietnamese don't work that much. So that means once such a system that can do very good, like top-level AI research is created, the day after you've got, say, several 100,000 equivalent top-level AI researchers. So maybe, the 5 best researchers at OpenAI, suddenly they become 500,000. That's going to accelerate research, and it's going to bring the next generation of AI much faster, and it's going to accelerate the advances. And then, the next generation will be designed by AI systems and will design itself again. So there's a potential from the point where we reach human level in AI research, that we create systems that will be quickly, like in a few years, superhuman, like completely off the chart of human abilities. So we don't know, but it is a plausible scenario. There was a recent study of researchers who published at the main machine learning conferences like NeurIPS, ICML, and so on. 3,000 researchers. And they asked a lot of questions. You can look at the study by Grace et al. But around 40–50% of these researchers believe that there's at least 10% probability that advanced AI will lead to catastrophic outcome as bad as human extinction. I'll say a few words more about why human extinction. Once we build machines that are smarter than us and we don't know how to control them, but you should already imagine a little bit, Okay, so why are we worried about building machines that, we program them to do what we want? What's the problem, right? Well, AI is about building intelligence and knowledge into machines. The question is, what do we do with that power? Who decides what the goals of these machines will be? It could be very beneficial goals, or it could be, goals that maybe are good for one person, but bad for the rest of us. And there are also some crazy people who, wouldn't mind if lots of people die. So there's an issue of concentration of power, right? If we build these machines that have superhuman abilities to strategize, to develop new technology, this technology can be military, could be how to achieve political influence with persuasion. There's already some recent study showing that GPT-4, when it has access to your Facebook page, is statistically significantly better than humans at persuasion, making you change your mind about a topic. Okay, they didn't compare with the FPT vendors, but just some university students, right? But that's GPT-4, and it's not even been tuned for persuasion, right? So there's a real danger that whoever will control these systems could misuse it. And, there's the potential that it could be destabilizing to the world geopolitics. Right now, there are not so many international conflicts because it's very costly to do war, because there's, a balance of power. Any country attacks another country is going to cost them a lot. Lots of people die, but it's going to cost them a lot. If one country thinks that they have a big advantage over their adversary, then they might do it, right? Let me go and explain quickly about, why we could have machines that could harm people. Well, there's the obvious case I discussed. Some people give the goal to the machine to design a weapon, like a bioweapon or a cyber attack that could destroy our infrastructure. But what about losing control to machines? Okay, that's another kind of scenario. In order to understand these scenarios, you have to understand there's one very special kind of goal. I call it self-preservation. Every living entity on this planet tries to preserve itself. Otherwise, evolution would have eliminated those species, right? What if an AI system has a self-preservation goal? And then we can ask, how does it get that goal? But what if it had a self-preservation goal? It sounds okay because, we have pets. They have self-preservation goals. But we are more powerful than the pets. Right? So if we build systems that have a self-preservation goal and are more powerful than us because they're smarter, that's a problem. If we want to turn them off, they might resist. For example, they could copy themselves over other computers using, cyber attacks. So now it's very difficult to turn them off. Before they do things that make us think that they're dangerous to us, they might make sure they're going to control us, for example. Or if there's an AI that's smarter than us and has a self-preservation goal and it has the ability to do it, the best thing for an AI to make sure it will never be killed by humans is to kill us. Right? I mean, if there is a balance of power between the AI and us, then that's fine, you know. But if there is no balance because these systems are a lot smarter than us, then we could be in trouble. So how could such a goal emerge? Well, there are two basic ways. One is some crazy humans give that goal to the machine. There are people who don't like humanity that much, and maybe they don't have children. I have children. I would like humanity to continue. But there are people who are cynical about humanity. There are people who think that intelligence is more important than humanity. And if there are superhuman entities, then they should be the ones ruling the earth. These people have made declarations. Some of these people are very powerful individuals controlling companies, very famous scientists, AI scientists, some of these. So that's one possibility. Even if just one person with enough power, you know, does it, then we might all suffer. So we need to make sure it doesn't happen. There's also another issue, which is what I mentioned up to now with loss of control, which is unintentionally, we could build a machine thinking it's going to be fine, but it ends up having a self-preservation goal. So the issue with those risks is that we're trying to build machines at our image. And it's natural. Humans have dreamt of building things like them. Even some religions are like, oh, we think God created us like God, right? So we create our children like us, right? But as I tried to explain, this may be very dangerous. If we create entities that are more powerful than us, then it could be the end of humanity. So maybe there's another path where instead of trying to build new entities that are like a new species that have complete autonomy, we just create very smart tools, things that are designed to serve us, things that are things, not beings. Things that are not even agents. So what is an agent? Okay, an agent is an entity that has a persistent state, has some goals, and acts to achieve those goals. So how could we build an AI that doesn't have goals, right? Well, we could have AIs actually pretty close to the ones we've been building that just know a lot of stuff and understand a lot of stuff, but don't have any like personal goals. So I'm going to develop that theme. And try to convince you that actually it's a much safer path, right? Okay, so this one explains what can go wrong with the way that we're currently training AI. We're training AI to be an agent with what is called reinforcement learning. So reinforcement learning is the same way that we train our cats and dogs. We give the AI some reward when it behaves well, and we blame it when it doesn't behave well. And through practice, it kind of understands what we want, but not perfectly. Like, if you have a cat, and each time it's jumping on the kitchen table, you shout at it, eventually it learns to not go on the kitchen table, if you are in the kitchen. If you're not in the kitchen, it goes on the kitchen table. What I'm trying to say is, there's a mismatch between what we actually want the machine to do, or want the cat to do, our intention, and what the AI or what the cat is learning. So with the cat, that's not a big deal if it doesn't fully understand what we want, because we are more powerful than the cat. If instead of a cat, it was a grizzly bear, okay, so we reward the grizzly bear with fish. Well, if it's a baby grizzly bear, maybe we can manage. But if it's an adult grizzly bear, more powerful than us, it doesn't care what we want. It's going to just take the fish from our hands. In the case of a computer, it's going to escape the computer on which it is running. It's going to take control of the computer on which it is running and give itself rewards. So you have to understand the rewards are the result of some computation, a piece of program in a computer. Some memory cells contain the reward. If the AI is programmed to maximize the reward that it gets, the best thing it can do is actually to take control of the computer on which it is running and write in the memory cell +1, +1, +1, +1, +1, +1, +1, right? To get rewards forever. So the way we're currently training our AI has as a mathematical solution that the AI, if it had the intelligence and the ability to do it, would take control of the computer on which it is running so that it gets maximal reward forever. And then it needs to make sure we can't turn it off, because otherwise that would stop the rewards. So it would have to control us or get rid of us. So it's crazy, right? Like, we're building machines that mathematically, once they get smart enough, will automatically turn against us. How do we avoid this problem of reward maximization? So something that is milder than maximizing reward is imitation learning. Actually, that already is what we do in the pre-training phase of large language models. They're trained to replicate the answers that humans give in different contexts. Because if you take a piece of text and you read the beginning, and then you ask, what would be the words that follow? That's just trying to imitate how humans would respond in different contexts. And so if we don't do the reward maximization part, the reinforcement learning, what we get are systems that imitate humans. And unfortunately, there are still things that are a little bit, that have some agency, because humans are agents. So if the AI is trying to imitate humans, and in a particular setting, if I was the AI and I know that somebody wants to turn me off, I would try to resist, right? But the AI is trained to do the same things as a human would do. So that's also dangerous. Not as much, because there's not this notion of taking control of the world, but it would still be dangerous. Next slide. Okay, so the other option that I'm trying to push forward in my research and trying to explain to the world, this maybe is a different path, is to build machines that are truly not agentic. So mathematically, what we would like are machines that can just act as oracles, okay, that compute the probability of an answer to a question, given all the training data. And you can ask, what can we do with that? Is it really safe? Next slide. And how do we build them? So first of all, it's actually very useful, because all of the scientific advances that we're hoping to get from AI, for example, in medicine and so on, we don't need agency. We need machines that are like very good scientists that understand the world better than us and can propose new scientific hypotheses and make us advance in biology and medicine and how do we fight climate change and other SDGs. I guess this is going to be my last slide because I'm out of time. So I have a research program to build these kinds of AI systems in which we use neural nets, but in a slightly different way. We use neural nets as generative models, but they're not trying to imitate people. They're trying to explain people's behavior. So they're trying to form theories, causal theories, of why people behaved in particular way. Why did somebody write this? So the problem with the LLM is that it's taking what is written for cash, right? It's like, say, it's just trying to do the same thing as a human would do. But what we actually want is, why did this person write this? Maybe they were truthful. Maybe they had some hidden intentions. So it turns out that you can formalize this mathematically as the problem of finding the Bayesian posterior over theories that explain the data. And I won't have time now to go into those details, but I've started writing about these things, and you can go to my webpage, my blog, and some of the papers there to get a glimpse of that. Thank you.